A camera right now next to Mars, at the Mars Reconnaissance Orbiter, it's really up to us to figure it out.
In 2014, something tore across the Pacific sky and left metallic crumbs nobody can fully explain. Now, an interstellar visitor, 3I Atlas, is blazing past Mars. Same neighborhood, bigger questions. Are we looking at nature's weirdest comet or the wreckage of something built? Let's follow the trail. The interstellar object 3I Atlas. When staring into the sky and spotting a faint object moving across the stars. Not a satellite or a regular comet, but something coming from beyond our solar system. That's what astronomers discovered in July 2025 when NASA's Atlas telescope in Chile detected an unusual object. It was quickly named 3I Atlas, the third known interstellar object to visit our solar system. Unlike typical comets, 3I Atlas wasn't looping around the Sun in a closed orbit. Instead, it was just passing through on a one-way journey. Its speed alone was staggering, clocking in at over 130,000 miles per hour. That's far faster than any object that forms naturally in our solar system. Astronomers quickly recognized that it must have come from deep space, possibly from another star system altogether. What made it even more fascinating was its trajectory. 3I Atlas came surprisingly close to three planets, Mars, Venus, and Jupiter. But it didn't come anywhere near Earth. Instead, it followed a path that placed it behind the Sun from our point of view, hiding it from most of our telescopes during its closest approach. That strange route raised eyebrows in the scientific community. If this object were purely natural, why was it behaving so differently? Some scientists saw 3I Atlas as just another interstellar rock. Others weren't so sure. The object had a long tail, like a comet, but its brightness and structure didn't quite line up with known comet behavior. As it passed through the solar system, it didn't break apart, spin wildly, or slow down in the way scientists expected. It remained intact, steady, and consistent. Its speed and path weren't the only things that made people curious. There was speculation that 3I Atlas might be more than just a comet. Some theorized it could be an ancient fragment of a distant planetary system. Others went a step further, suggesting it could be an artificial object, something built rather than formed. This idea might sound far-fetched, but it wasn't completely out of the blue. Back in 2017, another object named Oumuamua passed through our solar system. It had no tail, visible propulsion, and it sped up unexpectedly as it left the Sun's influence. That event started a wave of questions about interstellar visitors. 3I Atlas brought those questions back with new urgency. So far, 3I Atlas has avoided direct observation from Earth-based telescopes during its closest approach. Its position, hidden behind the Sun, has made tracking it nearly impossible. Still, several spacecraft stationed across the solar system have been redirected to observe it. Though originally built for other missions, scientists are using them in inventive ways to gather whatever data they can. Every bit of information could help reveal what 3I Atlas truly is. Is it just an ancient icy fragment flung from its home system by gravity's pull? Or could it be something more? Something that shows signs of intelligence or design? These are questions astronomers don't ask lightly, but with each new interstellar visitor, they grow harder to ignore. For now, 3I Atlas continues its silent journey, leaving behind more mystery than answers. Yet its brief passage through our solar system is anything but ordinary. A rare chance to study something born beyond our stars, and perhaps rethink what we believe about our place in the universe. 2014 Pacific Impact Mystery. On a quiet day in January 2014, something fast and fiery streaked through Earth's skies. It was just before dawn off the coast of Papua New Guinea when a meteor-like object entered the atmosphere at astonishing speed. It wasn't widely reported at the time, but years later, researchers would revisit this forgotten event and realize they might have missed something big. The object was officially cataloged as CNEOS 2014-0108. Its entry speed was over 130,000 miles per hour, fast enough to escape the pull of the sun. That kind of speed doesn't match with normal solar system meteors. According to calculations confirmed by the U.S. Space Command in 2022, the object came from beyond our solar system. It was interstellar. At first, the idea of an interstellar meteor seemed unlikely, but the numbers held up. The object entered at a steep angle and was detected detonating in the atmosphere 3 separate times. It impacted roughly 52 miles north of Manus Island. That explosion wasn't just atmospheric friction. It suggested the object had unusual strength, surviving deeper into Earth's skies than it should have. This data caught the attention of Harvard astrophysicist Avi Loeb and his team at the Galileo Project. They were already investigating anomalous objects like Oumuamua. IM-1, as this meteor came to be known, fit right into their research, and what made it more than just a curiosity was the possibility that parts of it had survived. Loeb launched an expedition in June 2023. His team set out aboard a research vessel, dragging a specially designed magnetic sled across the ocean floor in the area where the object was believed to have landed. Over 2 weeks, they recovered around 850 tiny metal balls, known as spherules. Most were consistent with natural meteoric materials, but a subset stood out. Roughly 10 to 20% of the recovered fragments had a unique composition. These pieces were richer in elements like beryllium, lanthanum, and uranium, elements rarely found together in such high concentrations in natural space rocks. Beryllium is used in neutron reflectors. Lanthanum appears in high-tech optics and electronics. Uranium, of course, is known for its role in nuclear energy. The findings weren't just surprising, they were difficult to explain. Tests confirmed the spherules weren't industrial waste like coal ash. They also didn't match known volcanic materials or tektites from natural explosions. They came from the ocean floor, right where IM-1 had impacted, and nowhere else. Scientists studying the particles began to question whether they were seeing something entirely new, or possibly even artificial. Some fragments displayed thermal patterns and magnetic rims, signs of atmospheric entry at high velocity. This suggested they weren't made on Earth. Theories started to form. Was this just a bizarre natural rock from a faraway star system? Or could it have been something more? Maybe even a piece of equipment that failed its mission and fell to Earth. Loeb and his team were careful not to make bold claims without evidence, but the data kept pushing them toward possibilities no one expected. IM-1 might have been the first physical object from outside our solar system ever recovered, and it may not have been random. The details of its strength, trajectory, and unusual composition point to something more complex. Whether it was a probe, a fragment of alien machinery, or just an incredibly strange rock, the questions surrounding IM-1 are real. As scientists plan future expeditions to retrieve larger fragments from the site, this discovery has sparked one of the most exciting scientific mysteries in years. Because if IM-1 wasn't just a rock, then it means something once sent it here. The ocean expedition. When a space object hits Earth, it usually leaves behind little more than a fireball and maybe a few scattered fragments. But the story of IM-1 is very different. It didn't just make headlines because it was fast or rare. It made headlines because someone actually went to the bottom of the Pacific Ocean to find out what it left behind. In June 2023, Harvard astrophysicist Avi Loeb and his team boarded a ship with one goal: retrieve physical evidence from the site where IM-1, an interstellar object, crashed nearly a decade earlier. This wasn't just curiosity. The object's speed, its deep penetration into the atmosphere, and its officially confirmed origin outside our solar system made it one of a kind. Loeb's team used a sled fitted with powerful magnets. They dragged it across the ocean floor, slowly and carefully, right where IM-1 was believed to have impacted. They spent 2 weeks scanning the seafloor looking for anything unusual, and they found it. Nearly 850 tiny metallic beads, spherules, were pulled up from the depths. At first glance, they looked like what you might expect from a high-heat impact, but closer analysis revealed something far more intriguing. The majority of the spherules had compositions that matched common meteoric material, mostly iron-based, similar to what's found in space rocks, but about 10 to 20% stood out. These were chemically different. They had elevated levels of rare elements: beryllium, lanthanum, and uranium. Not only are these uncommon in natural space debris, but their combination in one sample is almost unheard of. Scientists at Harvard's geochemistry lab ran extensive tests. They used scanning electron microscopes and elemental analyzers to confirm that these weren't pollution, volcanic byproducts, or industrial waste. They compared samples from outside the impact zone as a control and found nothing similar there. Among the standout finds were the so-called B-La-U type spherules. These fragments had unusually high levels of the 3 rare elements, in some cases 1,000 times more than expected in typical solar system material. That's when speculation deepened. Could these be manufactured? Were they remnants of a spacecraft or probe that was traveling with IM-1? The Galileo team didn't jump to conclusions, but they didn't shy away from the big questions either. The data pointed to something advanced, something not easily explained by natural processes. Later studies broke the spherules down by type. Scientists looked at their morphology and found that some of them had blocky or vesicular textures, typical of Earth materials, but others were coriaceous and stubby, with thermal stress features indicating high-speed entry from space. Even if only a fraction of them are artificial, that's enough to suggest that IM-1 wasn't just a meteor. It might have been a vessel, a scout, or something in between. D-type, artificial origins. When scientists began to sort through the fragments collected from the IM-1 crash site, one group of materials caught their attention almost immediately. These weren't just ordinary space rocks or natural remnants of a meteorite. They were different, chemically and physically. These fragments were labeled D-type, short for differentiated, meaning they had gone through some kind of change or processing before arriving on Earth. D-type spherules made up about 20% of the 850 total samples collected during the 2023 Pacific Ocean expedition. What made them stand out wasn't just their rare chemical makeup. To get a closer look, researchers placed the D-type particles under a scanning electron microscope. These terms describe how the spherules look under magnification. Some had bubbly surfaces, like volcanic rock. Others were more compact and rough, but 2 groups showed features that weren't typical of anything found in Earth's crust or in natural meteorites. They had spinel magnetite rims and signs of rapid cooling, known as quenching. This is important because it suggests the particles were exposed to intense heat, like that of atmospheric entry, and then cooled very quickly. That process would be consistent with an object that had traveled through space at extreme speeds, crashed into Earth's atmosphere, and partially survived. The presence of a magnetite rim indicates more than just impact. It points to high-speed ablation, a physical effect seen when something melts while plowing through air at hypersonic velocity. This alone suggested that at least some of the D-type fragments really did come from outside Earth, and they survived the trip. Now here's where it gets even more intriguing. About half of these D-type spherules belong to a category that scientists called B-La-U type. Beryllium is used in nuclear shielding. Lanthanum shows up in high-end optics. Uranium, obviously, is radioactive and extremely rare in natural objects from space. Finding all 3 in the same tiny bead is hard to explain with known planetary science. Could this be artificial? Maybe. That's what scientists are still trying to determine. One theory is that these fragments didn't originate from a standard asteroid or comet, but from the crust of an exoplanet, a rocky planet orbiting another star. Another possibility? That these are manufactured remnants from an object with some level of engineering behind it. Skeptics have tried to explain the Bielayu fragments as industrial runoff, like coal ash or volcanic debris, but detailed studies from Harvard's lab ruled that out. The elemental ratios just didn't match. Even compared to known Earth-based contaminants, the Bielayu fragments stood alone, and the fact that these were only found at the IM-1 impact site, and nowhere else, makes it unlikely they were just lying around on the ocean floor, waiting to be scooped up. Some scientists believe these materials may have been processed on another world. Others think they could be part of a structure, maybe a casing, a shield, or internal components from a probe. For now, no one can say for sure, but every test adds another piece to the puzzle. Asteroid ship hypothesis. After analyzing the strange fragments pulled from the ocean and comparing them with the behavior of IM-1 and 3I Atlas, a new theory started to gain traction. The idea of a hybrid object, something part natural and part engineered. It's been called the asteroid ship theory. Not a traditional spaceship with smooth metal and blinking lights, but a vessel built using raw materials from space itself. Think of it as an interstellar craft camouflaged as a rock. The idea might sound like science fiction, but it's actually rooted in real scientific strategy. Space agencies here on Earth are already working on in-situ resource utilization, using materials found on other planets and asteroids to build shelters, shields, and maybe even spacecraft components. It saves fuel, time, and cost. Now, imagine a civilization much older than ours doing the same thing, but across stars. That's what some believe IM-1 might have been. The bulk of the object, based on what we know, behaved like a meteor, but it didn't fully disintegrate, despite hitting Earth's atmosphere at over 130,000 miles per hour. It punched through deep into the atmosphere and scattered fragments that showed signs of unusual composition. This hybrid design might explain why only a fraction of the debris looks artificial. If most of the structure was rock and metal for shielding, and only specific parts were technological, like control systems or data storage, then we'd expect to recover mostly natural materials with a few strange pieces mixed in. Here's where the theory gets even more compelling. IM-1 and 3I Atlas didn't arrive randomly. Their point of origin in the sky isn't identical, but it's close enough to raise eyebrows. About 4.5 degrees apart in right ascension. In cosmic terms, that's practically the same neighborhood. It suggests a possible connection. If IM-1 was a probe, and 3I Atlas a mothership or scout vessel, the timing makes sense. IM-1 hit Earth in 2014. 3I Atlas was spotted entering the solar system in 2025. That's an 11-year gap. Enough time for one to scout, send data, and the other to follow up. Whether that mission was successful, or if IM-1 crashed due to a malfunction, we can't say. But the sequence of events suggests intention, not chance. There's also the structure of 3I Atlas to consider. It has comet-like features, such as a tail of dust and gas. But it's been acting strangely. It didn't come near Earth. Instead, it passed close to Mars, Venus, and Jupiter. It traveled at an incredible speed and kept a wide berth from any planet that might pose a threat. Some wonder if that's a sign of caution or avoidance. Astronomers have also been looking at speed and durability. IM-1 traveled faster than 95% of known stars in our galaxy and was tougher than any known natural meteor. Meanwhile, 3I Atlas is one of the fastest objects ever tracked through our solar system. It's also larger and more stable. If both came from the same origin, it suggests a civilization that knows how to build or use space objects that can survive long journeys. So when scientists compare IM-1 to 3I Atlas, they aren't just looking at paths and speeds. They're looking at a pattern, a possible mission, one that may have started long before we noticed anything. And if even part of this theory is true, if a probe came first and now its larger companion is flying through our solar system, then we might be witnessing a step-by-step approach from another civilization. Was it a crash? The idea that an interstellar object might crash into Earth isn't something most scientists take lightly. But that's exactly what may have happened in 2014. If IM-1 wasn't just a space rock, if it was a probe or even a hybrid craft, then its impact into the Pacific Ocean off Papua New Guinea could have been a failure. Or maybe it was intentional. The confirmation years later that it was interstellar, the fragments with unknown origins, and then a second object from a similar part of space moving through our system. It feels like a sequence, like a mission that had phases, and we caught only the aftermath of the first one. There's no smoking gun, alien circuit board, or propulsion unit recovered. But there is mounting evidence that something with an unknown origin entered Earth's atmosphere, behaved in ways we can't fully explain, and left behind debris that defies current understanding. If it really was a crash, then it may have been our first physical contact with interstellar technology, and we didn't even know it for nearly a decade. And now, with 3I Atlas making its journey through the solar system, we may be watching Phase 2 play out. 3I Atlas, dodging Earth? If you were watching the sky, you'd expect that anything passing through our solar system might take a look at Earth. It's the blue planet, the one with life, signals, satellites, clear signs of activity. But 3I Atlas, this fast-moving interstellar object, didn't swing by for a close-up. Instead, it passed close to Mars, Venus, and Jupiter, but skipped Earth entirely. That's not just curious, it's suspicious. The object was first detected in July 2025 and quickly confirmed to be moving on a hyperbolic path, meaning it came from outside the solar system and won't return. Astronomers tracked its speed and trajectory and noted something odd. At its closest approach, 3I Atlas was behind the Sun, hidden from Earth's view. It passed through the inner solar system while staying far from Earth's orbit, almost like it was keeping its distance. This pattern opened the door to speculation. Was 3I Atlas actively avoiding Earth? And if so, why? One idea is based on risk assessment. If this object was controlled or partially guided, then Earth may not have looked like a safe or desirable target. From space, Earth broadcasts all kinds of radio signals, but also military activity, nuclear tests, and environmental damage. To an outside observer, it might not seem like a stable or welcoming destination. Compare that with Mars, quiet, geologically interesting, and with active exploration, but no global threats. Or Venus, with its thick atmosphere and signs of past habitability. Or Jupiter and its moons, especially Europa, which might harbor life beneath icy oceans. These locations could be more valuable for research or observation. Another factor is visibility. During its closest pass, 3I Atlas was hidden behind the Sun from Earth-based telescopes. That timing couldn't have been worse for our observation, or more convenient for the object. It's almost as if its route was planned to avoid detection during its most active phase. In astronomy, most objects follow gravity, but if this one didn't, or if it adjusted its course slightly, then the path it took might reflect choice, not chance. Scientists have tried to track it using spacecraft around other planets. ESA's JUICE mission and NASA's Juno probe were both tasked with observing 3I Atlas as it moved through the system. These are some of our best tools to capture distant, fast-moving targets. But nothing replaces a close flyby, and 3I Atlas never gave us that. Next steps in space. After all the data, theories, and debates, one thing is certain: we're not done with this story. The arrival of 3I Atlas, combined with the mysterious crash of IM-1, has opened up a new chapter in how we explore the cosmos. The path forward now involves looking deeper, asking better questions, and using every tool we have to uncover the truth. Let's start with 3I Atlas. This object is still in motion. As of late 2025, it's moving behind the sun from Earth's perspective, making it hard to observe with ground-based telescopes. But space agencies aren't standing still. NASA and the European Space Agency are using spacecraft already positioned around the solar system to track it. These include JUICE near Jupiter, Juno in orbit around the gas giant, and Mars-based platforms like MAVEN and the ExoMars orbiter. Because 3I Atlas isn't coming near Earth, these distant instruments may offer the best chance to analyze its behavior. They'll look for changes in speed, brightness, tail structure, and surface composition. Any detail that might hint at what it's made of or how it's reacting to solar radiation. Even if we can't get close, every new observation helps complete the picture. Some scientists have proposed more ambitious ideas. Could we redirect a spacecraft to intercept 3I Atlas? It's a long shot. Most existing missions have limited fuel and fixed flight plans. But if we act fast enough, future probes might be designed with this flexibility. A sort of interstellar rapid response team, capable of catching these rare visitors before they disappear. As for IM-1, the work isn't done there either. Avi Loeb and the Galileo project are planning a second expedition to the Pacific crash site. This time, they're bringing more advanced equipment, including a remotely operated vehicle that can dive deeper and pick up larger fragments. The goal: to retrieve something that can't be explained away as a natural rock. This is where space science is headed, toward the physical, the tangible, the real. Telescopes are powerful, but sometimes the most important discoveries are made with a magnet, a net, and a boat. But the future of this research also depends on mindset. Some scientists are cautious, unwilling to leap beyond what the data can support. That's healthy. Others, like Loeb, are willing to explore ideas that sound bold, sometimes too bold, but are rooted in evidence and curiosity. Both approaches matter. We're also seeing new frameworks emerge. Loeb has proposed a kind of Drake equation for alien archaeology, a formula to estimate how many alien relics might be drifting through space, just waiting to be discovered. A lot deeper about communication, detection, and using Earth as a giant net, catching things that pass through and studying them with the rigor of science. Meanwhile, public interest is growing. Every time a new object enters our solar system, it sparks imagination. That something might be visiting or has visited is no longer dismissed as fantasy. It's becoming a valid line of inquiry driven by real-world data. So what happens next? We watch, scan, and prepare. The next interstellar visitor could arrive at any time. And whether it's a rock, a relic, or a probe, we'll be more ready than we were in 2014. This is the new era of discovery, one where every object might carry answers from beyond the stars. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and drop a comment below. I've got more great content coming soon. Stay tuned and take care till next time.